In this video, we will solve two torque problems, one with parallel forces and one with non-parallel forces. So, in this first example, a force of 50 newtons acts on a horizontal block as shown. The block is 1 metre tall. Calculate the torque about the pivot. This is a great example where we need to consider that line of action of the force. So what we do is just extend the line of the force and make it so that it finally meets that perpendicular distance from the pivot. So we can see that that perpendicular distance therefore is 1 metre. So it makes a nice simple question. So we have that torque is equal to F times by R, and F is 50 times by 1 metre to give me 50 Newton meters. So 5.00 by 10 to the 1 Newton meters. We can see that the block would be shifting from left to right, and so therefore it would be a clockwise moment. Let's consider our second example. An equilateral triangle of side 2 meters has a force of 13.86 newtons acting along side AB. Calculate the moment about point C. The first thing I want to do is pop in that pivot. Then what we can see is that the force is not at a right angle to that 2 meters that we've been given. So we need to find out what the perpendicular distance is between the pivot and that line of action of the force. So let me just extend that force there, and that will make it easier for me to see what that perpendicular distance is here. So there I've drawn it in the red. We know that this angle here is 60 degrees because it's an equilateral triangle. That means that this distance here, that perpendicular distance, would be 2 meters times by the sine of 60 degrees. Now we can do our problem. So we've got torque is equal to F times R times sine theta. So we have the force of 13.86 times by the distance of 2 sine 60. And if we pop that through our calculators, we end up with 2.40 times by 10 to the 1 Newton meters, so 24 Newton meters. And we can see that the triangle would be moving from right to left, so it would be anti-clockwise about the pivot. Okay, so that's two examples that I've shown you of torque. We will do some more complex examples in a later tutorial. Meantime, thanks for listening, and if you could subscribe to Dr. J, that would be great.